In this video, I'm going to show you how to apply the principle of decomposition to your programs. Computer programs are just a way to solve problems leveraging the power of computing. So before a computer can truly help us, we need to understand the nature of the problem we wish to solve. We need to have one or more problem-solving recipes known as algorithms in mind. Make sure you return to the presentation and check out this video from BBC Learning about algorithms. Algorithms, the ordered step-by-step instructions to solving problems, can often be detail-oriented and complex. Therefore, in order to communicate algorithms clearly to all parties and to manage complexity, programmers and analysts have developed multiple strategies for vividly describing these algorithms. One such strategy is the use of so-called pseudocode, which allows the algorithm to be described in plain old English. Another strategy involves the use of flowcharts, which employ shapes and arrows to visually step someone through an algorithm. In a flowchart, each symbol means something, and arrows direct the flow. Here's an example flowchart describing the algorithm used at a car parking lot with a set number of parking spaces. Hopefully, you can see how effective this technique can be when applied to a process of any significant detail. Pseudocode isn't actual code per se, so you will see many forms of it, both written and graphical. By the time you go to actually write a program that implements your algorithms, you should have already analyzed the problem and its solution in some detail. They call it programming, but one could argue that it should be called thinking, because by the time you sit down to write the code, most of the work should already be done. In other words, writing code is kind of a formality and relatively easy, especially when you think twice and code once. Computer programming can be complex, so the practice of writing one humongous blob of code is frowned upon. To program effectively, we need to employ the principle of decomposition. In other words, we need to break problems down into their parts. By solving a series of smaller, simpler problems, we end up with a solution that is simpler than the whole. Decomposition is a generic, abstract principle that can be applied to any problem, irrespective of whether a computer is involved. In this example, I decomposed a solution to an important, age-old problem, asking a girl out. A solution to a daunting problem is much easier to implement when broken into its distinguishable parts. Now let's shift gears and look at this in a programming context. Imagine I had a simple program that sang the hokey pokey. Without any kind of decomposition, it would be implemented as one big sequential blob of code in a single method. But when we decompose singing or doing the hokey pokey, we see that it is composed of distinguishable parts, complete with repetition and redundancy. I have broken the hokey pokey into 3 subparts, each with its own details. So, when I go to rewrite my code, I refactor it into 4 methods, one for each solution subpart, and then I include a method which uses each subpart in a flexible way. This is what decomposition looks like when applied to programming. The fancy technical term for this is procedural decomposition. When we factor our code into subroutines called methods in Java that do just one thing, we are using procedural decomposition. Java is an object-oriented programming language, but we haven't gotten to objects yet, so we will begin by writing multi-method classes using what are called static methods. In time, you will be able to distinguish between the 2 general families of methods, static and instance. Static methods are a great place to start, however, because they belong to the class, and as such, we don't need to create an object to use them. Declaring a method in Java is quite logical, but there are a lot of parts to it, so it can take some time to master. A method consists of a header, often referred to as its signature, and a body. The header describes the basic properties of the method, and the body contains the code that is executed when it is run. Once a method is declared, it can be used by calling it by its name. Some methods accept arguments that you pass in when calling them. If a method does not accept any arguments, you simply call it by its name, followed by empty parentheses and a semicolon. When a method is encountered in your program, control is passed to that method, and its code is executed. Then control is passed back upon completion. In programming parlance, the order statements are executed in is normally referred to as flow of control, or simply control flow. This idea that code jumps back and forth is central to understanding procedural programming. Programmers have a rich vernacular that you will adopt in time. For example, when you execute a method, you are said to be calling it. You are the caller. Additionally, methods define parameters, but when you pass values in, you're actually passing in what are called arguments to the method. With enough exposure, you'll be talking the talk in no time.